All right, lesson 28, simplifying rational expressions. So a rational expression is the quotient of two polynomials. That's what we're talking about, when we have a polynomial divided by another polynomial. Now, because of how this all works, let me write it again up here so that you can see it how it's really meant to be written. 2x squared plus 4x minus 4 divided by x plus 3. Okay, that's the better way of looking at that. Hopefully we understand how it's typed in there. As with any fraction, the rule that we have here is that the denominator cannot be equal to 0. Why can the denominator not be equal to 0? Does anybody know? Right. If I divide anything by 0, it's going to be undefined or unreal. Okay, imaginary. It doesn't exist. Okay, it would be the asymptote of the graph. Okay, so what you'll notice here is that this becomes undefined when x equals -3. And the reason why is because we're going to take our denominator here, right, and we're going to set it equal to 0 so to find out what the 0 is. So we would take x plus 3 equals 0, and we would subtract the 3, so we'd see x equals -3. When x equals -3, it causes the denominator to equal 0. So of all the values in the world that we could come up with, the one value that we cannot plug in for x is -3. Because if I plug in -3 for x, it causes my denominator to be 0 and therefore undefined. Do you follow what I'm saying? Okay? So it's not defined when x equals -3 because -3 plus 3 equals 0. In any function, this is what we call an excluded value. All right? It is a value that causes my expression to become undefined. An excluded value is a domain value or an x value that makes the range undefined. For the function above, we saw that -3 is an excluded value. Not all rational expressions have excluded values, and some have more than one. For instance, we can see over here, -3x divided by, or sorry, -3x minus 6 divided by 4 has no excluded value because there's no situation that I can plug in a value for x that's going to give me an undefined solution. Okay? Because I'm not substituting anything in for the denominator. If I look over here at this right-hand one, the denominator does have an x, but even if I plug in a negative value, right, because I'm squaring it, I'm going to wind up with a positive value, and it's addition, so there's no way of canceling it out so that I get a 0 in the denominator based upon how that's set up. So for instance, we would say, x squared plus 2 equals 0, right? If we're going to try to find the 0, we would subtract 2. We'd say x squared equals -2. Okay? Well, if I square root both sides, I'm getting x equals positive or negative square root of -2, right? That's not something I really have to worry about, okay? All right. Now down here, we have multiple excluded values, okay? For this one, we would go ahead and we could factor this denominator down, right? We've got x plus, let's see, should be 2 and 1, right? And in those cases, x equals -2, x equals -1. Both of those values would give me zeros in the denominator. Does that make sense? Okay. So that has more than one excluded value. I can't plug in -2 or -1 for x. Anything else but those two things. Okay? All right. I know some of you guys are writing down. I really appreciate that. Tell me whenever I can move on to the next slide. Am I good? Okay. All right. So a rational expression is simplified when there are no common factors other than one in the numerator and denominator. These are two examples up here where it's already simplified. There's nothing else to do to it. Down here, we see a couple. We see two different things that are not simplified. First off, in here, I can move this x to the 4th, right? And we could factor x to the 4th out of it, out of the whole thing. Okay, so that's the common factor out of the numerator and denominator. Over here, my common factor is x minus 7. So I could factor that out of both sides, or both the top and the bottom. Okay, so it's only simplified when the factors between my numerator and denominator are down to just 1. Okay. Rational expressions with monomial numerators and denominators are best simplified by using the quotient of powers property, which states that to divide two powers with the same base, we just subtract the exponents. We should be fairly familiar with that. Like if I got x to the fourth over x squared, that's going to be x to the fourth minus 2 or x squared. Right? We're familiar with that? Okay. All right, and that's what you see in that example. All rational expressions can be simplified by dividing out the common factors that appear in both the numerator and the denominator. When negative 1 is factored out of something like b minus a, all right, if I factor a negative 1 out of there, right, the result is negative 1 times negative b times a. And if we test that, we'll see that it works because negative 1 times negative b is positive b. Negative 1 times positive a is negative a. I get what I started with. All right, which can be rewritten as negative 1, and then we just flip it so that my a, which is positive, comes first, minus b. And that's how we'd really rather see this written. Okay, rather than having a negative variable show up as the first term in my parentheses. This result allows opposite binomials to be factored out of a rational expression. So when we can, we want to factor out negative numbers so that we have a leading coefficient that's positive. Okay, I think that's it for that. So let's see if we can answer a question or two. Let's see, I got a few minutes anyway. Some of this stuff we've already done from the other day, but we're going to pick up the questions that we haven't done, like number 2. We want to identify any excluded values and then simplify the expression. All right, so we need to find the excluded value. What can I not have in the denominator? 0. How do I find out what the excluded value is going to be then? What do I do, Axel? How do I find the excluded value of this expression if the denominator cannot be 0? Nope. I just want the excluded value for now. I can't have 0 in the denominator. How do I find out what the excluded value will be? We worked out a couple examples like this just a little bit ago. The denominator cannot be equal to 0. So shouldn't we find out what would cause the denominator to equal 0? That would help me find the excluded value, right? Okay, so what would you do then? What is the denominator? 7b plus 5. Okay? What should I put on the other side of that? What should I set it equal to? No. 0. Why? Because I'm trying to find the excluded value, the thing that would cause the denominator to be equal to 0. Okay, now what do I do? Subtract 5 from both sides. So I got 7b equals negative 5. What's next? Divide by 7. So b cannot be what? Negative 5/7, because if I plugged it in, I would get 0. Okay? We see that show up really just here. Now, if we're going to simplify the expression, simplifying the expression is a totally separate thing. Okay? Do we understand how to find the excluded value? All right, so simplifying the expression comes from factoring. Okay, let's look at the top. What can I factor from the top? 7. Okay, so if I factor 7 out of the top, what is left inside the parentheses? 7b plus 5, right? And down here, I still have 7b plus 5, correct? What would happen to the 7b plus 5s? They would cancel. Okay? So what am I left with? What is the simplified version of that? 7. So I'm looking for an answer of 7 and the excluded value of negative 5/7. We follow how to do that? Okay, great. All right, we need to look at least one more, I think. This is no, let's see, we've done that, I think, although it's pretty similar to what we've looked at. All right, let's look at number 5. Okay, try this again. We want to find the excluded value. What am I going to do? M to the 5th equals 0. All right, so how do I get just m? What do I have to do? No, not divide. What's the opposite of an exponent? Not square root, right? That would be the opposite of m squared would be the square root of m. A fifth root be the fifth root of m. Well, what's the fifth root of 0? 0. So 0 is an excluded value, right? Okay. So we see that actually show up for 3 of them. So we know 0 is an excluded value. Now, we want to simplify it. So what do I have there? Angeli? 8 minus 5. So we'd have m to the 8 minus 5. What's that going to be equal to? M to the m cubed. So we want m cubed with an excluded value of 0. Okay? And even if, you could see, well, if I plug in 0, right, I've got 0 to the 8th over 0 to the 5th. That's 0 over 0. Go ahead and try this in your calculator real quick. What's 0 divided by 0? You'll still get an error. You'll still get an error. It doesn't matter that you're dividing 0 by 0. You cannot divide by 0 no matter what it is. You will always get an error. It is always going to be excluded. Okay, does that make sense? All right, do we feel like we've got somewhat of an understanding of what we've covered here today? All right, great. You got questions? Let me know.